Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 8, Lesson 4 on distance in the coordinate plane. So obviously, you plot a lot of points in the coordinate plane. Oftentimes you draw segments in between them, but you've never been forced to find the length of those segments unless, of course, those segments were completely horizontal or completely vertical. All right? In today's lesson, we're going to see how to use the Pythagorean Theorem to find the lengths of segments that are slanted, if you will, in the coordinate plane. Let's take a look at how that's done in a first simple exercise. Now, you will want your calculators because some of the numbers that we work with today are going to be a bit messy, but, just make sure to have them handy and ready to go. Now, a great deal of modeling is done in the coordinate plane. Being able to find the distance between 2 points plotted is essential. Let's start in exercise number 1. All right. 2 points A at 0, 6 and B at 8, 0 are plotted below and connected with a straight line segment. Letter A asks us to redraw a right triangle that has segment AB as its hypotenuse below. Label the known side lengths. You see, one of the great things about the coordinate plane is that all of these vertical grid lines and these horizontal grid lines are by definition perpendicular to one another. So, this line segment then can be thought of as the hypotenuse of this right triangle. Right? And it's a right triangle again because we've got this right angle. I mean, all those little things up there are squares. So we can redraw this thing, right? We can actually kind of put it down here out of the coordinate plane. All right, what we definitely know is that this length is 6, right? It just comes from here. And this is 8, that comes from here. This is still point A, and this is point B. All right, but now we've got a right triangle, which means our good friend, the Pythagorean Theorem, can come into play. Let's take a look at letter B. Use the Pythagorean Theorem to find the length of AB. No units are necessary. All right, so in other words, I need to find the length of AB, and I claim I can do it using the Pythagorean Theorem. Now, after the last 3 lessons, you're probably like, of course you can use it to use the Pythagorean Theorem. I've got a right triangle. I've got 2 sides that I know, a side that I don't know, and specifically, the one that I don't know, right, is the hypotenuse. I don't know C. So, we can now use the Pythagorean Theorem. Maybe I'll let this be equal to A, and this be equal to B, right? We know the Pythagorean Theorem says that if I take A and I square it, I take B and I square it, and I add them together, I'll get C squared, right? So I'll get 6 squared plus 8 squared is equal to C squared. I think I'll do this one without my calculator. The numbers are small enough and nice enough for me. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. So C squared is 100, and C is the square root of 100, which is 10. And that is the length of line segment AB. We also consider it the distance between A and B. So the title of today's lesson is Distance in the Coordinate Plane. But distance and length, right, they're the same thing, right? So the distance between points A and B is 10 units. Literally, if I measured out 10 of these units in a horizontal or a vertical direction, and then I took that line segment and I lined it up, it would be the length of AB. AB is 10 units long. And the remarkable thing is that we can use the Pythagorean Theorem to find the distance or the length of a segment between 2 points at any point in the coordinate plane. So let's see how that's done a little bit more generally. Let me bring this over here. And let's take a look at another example. All right, exercise number 2. Consider the points A, 3, 2, and B, 9, 6. Plot the 2 points on the grid and connect with a line segment. All right, that's no problem. Why don't you pause the video and go ahead and do that. All right, let's do it. So we've got 3, 2, which is right here. And we've got 9, 6, which is right there. So I'm going to connect them with that line segment. All right, great. Letter B. On the grid, draw a right triangle using AB as the hypotenuse with the legs vertical and horizontal. All right, so this is my hypotenuse, and spoiler alert, it always will be. In fact, one of the nice things about finding distance in the coordinate plane using the Pythagorean theorem is we will always be solving for the hypotenuse. We'll always be solving for C, because when I draw in my right triangle, the legs will be these horizontal and vertical line segments, right? So there's that right triangle. Now, letter C, determine the distance between A and B, round to the nearest tenth. All right, well, let's at least do a little bit more work here. Maybe I'll draw my triangle, my right triangle down here, right? And what do we know? Well, we know that the length here is 1, 2, 3, 4, 5, 6 units. And we know the length here is 1, 2, 3, 4 units. And I can just simply do that by counting, right? Now, to find the distance between the 2 points, right, and really A is kind of sitting down here, and B is sitting up here, I am just going to use the Pythagorean theorem and solve for my hypotenuse. Why don't you pause the video and do that now? Keep in mind you're going to be rounding your answer to the nearest tenth because the actual hypotenuse will be an irrational number in this case. Pause the video now. All right, let's do it. So let me just give myself a little more room. We've got 6 squared plus 4 squared is equal to C squared. 36 plus 16 is equal to C squared. C squared is equal to 52. This is where I'm going to have to bring my calculator out because I cannot do the square root of 52 in my head. 52 is not a nice perfect square. Let's clear this out. Square root of 52. And C is going to be 7.2, rounded to the nearest tenth. All right, it's that easy. Now, one thing I wanted to note, right? I figured out this length by literally counting, literally going 1, 2, 3, 4, 5, 6, right? And then I figured out this length by also counting 1, 2, 3, 4. That's fair game, and there's nothing wrong with doing that. But hopefully there's an easier way to get those horizontal and vertical leg lengths without having to count. So let's explore that in the next problem. All right, exercise number 3. The diagram of the right triangle you drew in exercise number 2, the one we just did, is shown below without the grid shown. How could the horizontal and vertical leg lengths be found using the coordinates from the endpoints? Illustrate. All right, so again, here's the idea of where we're going on exercise 3, and then I want you to think about this a little bit on your own, right? I'd like to be able to figure out this 6 and the 4 without counting squares, all right? And I claim you can actually just look at the coordinate points and they will tell you that that's 6 and 4 without actually having to count any squares. So pause the video now and see if you can figure out where this 6 and 4 come from just based on the coordinate pairs. Well, all we have to do is subtract the x and the y coordinates from x and y from y. Here's what I mean, right? This x coordinate, let's actually get these points bigger here. 3, 2, right? And b at 9, 6, right? Literally, this 6 units just comes, right? So the horizontal leg literally just comes from doing 9 minus 3 and getting 6, right? That's where that comes from. This thing's at 3, and then you go 6 units to the right, and you get up to 9. So to figure out that 6, I can just do 9 minus 3. Likewise, this thing starts at a y-coordinate of 2 and goes up to a y-coordinate of 6, right? And therefore, the vertical leg equals 6 minus 2 is equal to 4. So we can always figure out the horizontal and the vertical leg lengths by simply subtracting x from x and y from y. So let's take a look at that in the next problem. Exercise number 4. Consider the points E, 4, 3, and F, 9, 15. Do the following. Letter A. Find the length of the horizontal and vertical legs of this right triangle using subtraction. All right, so it's really this simple, right? If I want to know how long the horizontal leg is, I'm just going to take this x-coordinate and this x-coordinate, and I'm going to subtract them to figure out how long that leg is. Right? What is the distance between 4 and 9? It's 5 units. Now to find the vertical leg, I'm going to take this y-coordinate and I'm going to subtract off this y-coordinate. Again, how much distance is between those two coordinates? And that's 12 units. And that now gives me my two legs, 5 and 12. Letter B. Draw a diagram of the right triangle formed and find the distance between E and F. All right. So in other words, it doesn't have to be perfect, but what I know is if I've got point E and point F, then that horizontal leg was 5 units long, and that vertical leg was 12 units long. I can now find the distance between E and F by using the Pythagorean Theorem, which, for the distance formula, will always be the length of the hypotenuse. Pause the video now and figure out the distance between points E and F. All right, you might be getting used to this Pythagorean triple, the 5, 12, 13 Pythagorean triple, right? It comes up just about as often as our 3, 4, 5 Pythagorean triple. Let's do it. We've got 5 squared plus 12 squared is equal to c squared. All right. That's 25 plus 144 is equal to c squared. C squared is equal to 169. Take the square root of both sides. C is the square root of 169. C is 13. And that's it, right? And it really kind of is that basic. If you're given 2 points in the coordinate plane, right, those 2 points, if you draw a segment between them, all right, would be the hypotenuse of a right triangle. The 2 leg lengths then can be found by simply subtracting the x-coordinates and subtracting the y-coordinates. Now, where things get tricky is if negative numbers get involved. So let's talk about that a little bit in our final exercise. All right, we can find the lengths of the legs of a right triangle in a distance problem by subtracting the x, y coordinates and then finding the absolute value of the difference. Now, you might say, well, we didn't find the absolute value of the difference in the previous problem, and that's because both differences were positive numbers. And if you find the absolute value of a positive number, it's still just a positive number, all right? But in exercise number 5, things are going to get a little bit trickier. So let's take a look at exercise number 5 and see how we deal with some negative numbers getting involved in these situations. Let's see what exercise 5 says. For each set of points below, first find the length of the horizontal and vertical legs, then find the distance between the points using the Pythagorean theorem. All right, so let's do it. Now, I really don't want you to just be plugging numbers into formulas. I want you to think about it for a second, right? I've got a point that's at negative 210 and another one at 6, 5. And the horizontal leg is going to be how far we are to go from negative 2 to 6. What is the distance between negative 2 and 6? You can probably just think about that in your head, right? It's 8 units, right? To go from negative 2 to 0 would be 2 units. Then to go from 0 to 6 would be another 6 units, so it would be 8 units. Now, if I want to do it with a formula, this is what I would do. I put some absolute value bars. I do 6 minus negative 2. All right. Now, the only reason I've got the absolute value bars here is in case when I subtract, I get a negative number. Now, in this case, I won't, because 6 minus negative 2 is positive 8, and the absolute value of positive 8 is just positive 8. Side note, if you can just look at the thing and go, between -2 and 6 is 8 units, awesome. Awesome. You don't need to do this. The worry is that you might look at 6 and -2 and think that there's only 4 units in between them. Because you might go, oh, 6 minus -2 is 4. Now let's look at the vertical leg. Now the vertical leg is going to be the distance between 10 and -5. And again, you might be able to just think about that and go, well, between 10 and -5 is 15 units, right? Just think about it, right? From 10 down to 0 is 10, and then from 0 down to -5 is 5. 10 and 5 gives me 15. All right. But if not, you just simply need to subtract the two and then make sure your answer is positive, because we're talking about distances here. We're not talking about anything else, distances. -5 minus 10 is -15, and the absolute value of -15 is positive 15. Again, if you can come up with the 8 and the 15 without having to write down the subtraction and the absolute values and all of that, that's awesome. Ultimately speaking, all I'm looking for is how far the two x coordinates are away from each other and how far the two y coordinates are away from each other, and those happen to be 8 and 15. Once I have those, I can then use the Pythagorean Theorem and basically just say, look, I've got 8, I've got 15, I want to know now my hypotenuse, so let's do a little Pythagorean Theorem, right? We'll have 8 squared plus 15 squared equals c squared. I think we'll use our calculator to do 8 squared plus 15 squared. That gives me c squared equals 289. C will be the square root of 289. Let's see what our calculator gives us for that. The square root of 289 is 17. So that is the distance between those 2 points. 17 units. All right. Now again, this is a little bit tricky. Just keep in mind, right, the horizontal leg is how far the two x coordinates are away from each other, which you can always find by subtracting. And if that subtraction is negative as a result, turn it positive, because distance is positive numbers. Likewise with the y's giving you the vertical leg. See if you can do this in the last problem of the day in letter B. All right, let's do it. So our horizontal leg, right? That's going to be how far 7 and -5 are away from each other. If you can look at that and say 12 units, awesome. On the other hand, if you have to say, well, I'm going to do -5 minus 7, which is -12, and then find its absolute value because it's a distance, that works as well, right? Now the vertical leg's quite easy. That's from 2 to 11, right? And there's 9 units between those two. Right? I can just kind of think about that, but if you like the formula approach, right, I'm going to have the absolute value of 11 minus 2, which is the absolute value of 9, which is just 9. Again, I'm just looking for how far these two numbers are apart from each other. And now I've got my vertical and my horizontal legs. You don't even need to draw a picture, but it's kind of nice to have one, right? We know that the horizontal leg is 12, the vertical leg is 9. That looks like a square root symbol, which is a bit weird. And now it's like at right angles. There we go. All right, I want C. So I'm going to have 9 squared plus 12 squared is equal to C squared. 81 plus 144 is C squared. C squared is 225. C is the square root of 225. And C is equal to 15. All right. And that's it. Okay. Now again, this can be tricky. All right. But all we're doing essentially is we're finding out the leg lengths of a right triangle by using subtraction, and then using the Pythagorean Theorem to find the distance between the 2 points. It's kind of cool. Eventually, In geometry, when you take high school geometry, you will formalize this process a lot more in what's known as the distance formula. But for right now, we're going to find distance in the coordinate plane, right, by basically plotting 2 points or just knowing their coordinates, right, having a right triangle whose hypotenuse is the line segment that goes between the 2 points, and then finding out the length of that line segment by figuring out the horizontal distance between the 2 points by subtracting their x-coordinates, the vertical distance between the 2 points by subtracting their y-coordinates, and then using the Pythagorean theorem to find that hypotenuse. One thing that's kind of nice about distance problems in the coordinate plane is that when we use the Pythagorean theorem, we are always using it to find the hypotenuse. We're never using it to find one of the missing 2 side lengths. I suppose some problem could be gimmicky where they give you the distance between the 2 points and then you know one of the 2 side lengths, I guess, and then you try to find the other one. But typically distance problems are very straightforward. Here are the 2 coordinate points. What is the distance between them? All right. In our final lesson of this unit, which will be the next lesson, we're going to just look at why the Pythagorean theorem is true, which is kind of cool. But for now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.